Okay, the visitor pattern. So that's the last bit of formal content I have today, and then we can go to Q&A. So the visitor pattern. So why do we want to use this visitor pattern? So there's a number of uses of the visitor pattern. So one of the things that you can do with the visitor pattern is you basically can go into a data structure without knowing how the data structure actually is structured. So you just can iterate over the elements and it works automatically. And normally you'd have a visitor object have multiple different callbacks depending on different types. So basically your data structure can say, okay, if it's an integer, do this, if it's a double, do that, call that, and the visitor calls those things, and it might even have a return value that then allows the visit function to basically have the results in a structure. But it doesn't have to, because your visitor could also accumulate those itself. So your visitor object will be able to respond to elements, and in particular what it also allows is to add all this kind of functionality without having to change the visited object. The object you visit just needs to have the visit method, and then you can have many versions of methods that use this. You can even, in Kotlin, make an extension function upon the visited object to make it look like it's a regular function that does something with the elements, but actually use the visitor underwater to make this work correctly. And a particular thing that you can do with visitor pattern is do double dispatch. So double dispatch is something that, say, Java and Kotlin don't support natively. So single dispatch might be an interesting thing to first talk about. So what is single dispatch? Single dispatch means that the function that is invoked when you call it upon an object depends on the type of the object that you call that function on. So dynamic dispatch, so it dispatches the function based upon that. But sometimes you might also want to do something based upon a parameter. And with visitors, you can actually do that in a limited way, while being type safe and all those other things that we want to achieve. So what does this look like? So in this case, I could have added multiple visit functions. So we have a visitor that implements a visit function, and then when we have another class that uses visitor, and it will just call the visitor with a number of parameters. It could do something more interesting and have some state that it passes it, but in this case it doesn't matter. Then we can have an implementation of that visitor that actually provides an implementation of visit int, and says in this case it calls print line, but it could also say int colon I, so it could do something more, and it could have a boolean or visit string, and it could print the contents of your A object in whatever way you like. The A object doesn't need to care. So when we use this, what we do is we need, of course, an instance of the visitee, we need an instance of the visitor, and then we call the visit function of the visitee with the visitor, and that will print our data. So that is the visitor pattern, and it is quite a clever trick, and it's very close to our callbacks and stuff like that. It is again a way of indirecting, and in particularly what you have often in a data structure is that you actually know underlying types, and then you can call those underlying types with the right visit method, so that the right visit method actually can then work with that particular type. Or you have different objects that implement visit in a different way. So you call the visit function with the visitor, and then depending on so your first function says, okay, I need to do this. I create a visitor depending on what type I am with dynamic dispatch, and then the visitor can be visited based on the, and then you visit the parameter based upon with the different visitors that you get from the dynamic dispatch, and that the visit function then will call the right visit function based upon what it is. That's how you get this double dispatch.